Hi, everyone. Um, just a little accessibility reminder. You can turn on live captions. Use the three dots, the ellipses in the top right-hand corner to be able to turn on those live captions. I know they help me when I'm listening to talks. So let me share screen. As Benny said, we take a very modular approach to building AI solutions and data solutions in the cloud because there really is no one perfect answer when we create a technology solution. And all of these solutions end up living software artifacts. So it's not just making sure that the solution we build first meets the requirements, but that we're able to flex and change our solutions so that as we get further requirements, that we can adjust our solution to match. So today I'm going to build a pipeline to get data, to be able to analyze it using some off-the-shelf capabilities, and be able to get the results in real time into a solution so that we could be analyzing it or presenting it in things like Power BI. We're going to use Twitter data for this, so you can grab my Twitter handle, but the most important thing is going to be the Datamines hashtag. This is our real life data source so that we can prove that there's no kind of magic up my sleeves on this. The solution is also going to be available on GitHub. So I'm currently live coding a workaround because there's some recent changes in the Microsoft stack that meant my WYSI deployment. Here's one I made earlier, did not work. But you'll be able to go and see some common instructions on how to set up a pipeline and how to actually specify those in code so that you can deploy them again and again and add a level of robustness and quality around the infrastructure we use. In terms of creating resources, we're able to use Bicep, which is a nice way to specify our Azure resources, GitHub Actions or Azure DevOps to be able to, whenever we make a change, update our infrastructure, and the Azure CLI to be able to provide instructions to Azure in a scriptable fashion. So I'm going to show you some of that, but I'm not going to be using it because, as I said, Microsoft made some changes that my pre-baked one doesn't work today. You can see all of this online in GitHub as well, but we have a number of parts. So this is a Bicep specification of an infrastructure. Bicep is named because it's a pun on ARM templates, Azure Resource Management templates, and is a way to specify things in a kind of a simpler fashion instead of writing pure JSON. We're able to create variables which give us and have functions that return information about resources. We can create storage accounts, event hubs, cognitive services, and information to be able to even use no-code solutions to be able to perform AI in real time and at scale. So you can go online and you can see the Bicep, and there's an Azure extension for Bicep that helps make your life easier when writing this. And then this goes through Azure through GitHub and an action. And we're able to specify when that action takes place. So every time I push some new code, we're able to provide some information about what things should be called. And then we're able to specify our steps that our solution should do. So for instance, we can use the Azure CLI to build that Bicep file into an ARM template. You can directly deploy the Bicep file now, but it can be very handy creating that ARM template for compliance and audit purposes. We're able to connect via a service principal, so we can have secure deployments into our production environments. We can send instructions around creating resource groups, and then we can also use deploy activities and other pre-scripted ones to be able to provide details to go and then deploy an ARM template. And this is useful because it gives us traceability and debugging of our process. So I was making this Logic Apps version today around about 5 hours of meetings. So I'm just fixing up a last bit here, and unfortunately it didn't work. But I'm able to go through, see the problem, look for the error message, and be able to start kind of fixing that inside my code. I'm not going to live hotfix that code, don't worry, but it is usually a smooth workflow. And the great thing is it isn't smooth when there's important changes. So I have not screwed up my Azure environment, because when there's a problem, it doesn't deploy. So anything that's truly buggy and doesn't build never actually hits even my development environment, ensuring that extra bit of quality. So that's how I would normally do it. Before I start kind of going over some more of the detail on real-time AI processing options, a little bit about me. I run my own tech company. I'm trying to make no-code AI solutions a thing for manufacturers. I love helping people learn, so I am very kindly awarded the AI and Data Platform MVP Awards. You can connect with me on Twitter and LinkedIn, and I'll also share my email address at the end of the session as well for if you have any further questions. So I've talked about the kind of some of the infrastructure bits, the Bicep and things like that, that help you deploy a real-time pipeline. But I'm going to do a lot of it from scratch here to be able to do some of this to show it to you and navigate some of the problems that I had. So when we're building a real-time pipeline, you first of all need to make sure that you have the resources available in your cloud environment to perform your AI based analysis. So that could it could be a machine learning API from Azure ML. It could be a custom language understanding solution. It could be a custom vision solution, but you need something that will actually perform AI, store data, and be able to process it. If you're thinking about a real-time system, you need to think about the signal, the thing that is going to trigger your real-time analysis. So I usually do an event-based signal. So I look out for something happening, and then my AI pipeline reacts to that solution, to that signal. you need something to be listening out for that signal. So you need something that's either going to regularly poll a data source, or be able to be triggered by the event, by the signal occurring. We then refine the data we receive from that real-time source to be able to gain insight. So that's where we usually put in our AI to be able to enrich our data as it's flowing through from our source systems into our analytical environments. Then we persist that data. So we need to make not just the original event, but the AI enriched data set available somewhere. And then we actually need to use it in some way. And one of the first ways that we need to be able to understand our data and the things that are happening in real time is to be able to visualize the data itself. So each of these different each of these different kind of core capabilities, when you're building a real-time solution, has a broad array of options in Azure. So a good place to start in Azure with a signal is to make something events driven. And in Azure, there's event hubs, which is great for behind an application, and IoT hub, which is great for lots of different devices generating events. To listen out to a signal, to be able to react quickly, to be able to process it effectively, there are 4 great technologies we can use. There's Azure Functions, which is a code-first solution that allows you to do event-driven capabilities. There's Azure Logic Apps, which is a no-code process specifier, and I'll end up using that today. Stream Analytics, which reads data and aggregates it and writes out the results into a data store. And then Azure Databricks, which also doubles up for Azure Synapse Analytics. The Spark streaming capability can listen out for events, including from Azure Event Hubs. So we can use Databricks and Synapse as a listener, as well as using it for its broader Spark and SQL capabilities. We can enrich our data in a whole number of ways. So cognitive services is a great way to leverage Microsoft's data science expertise. We can use their pre-created APIs or customize some of the solutions to be able to process text, speech, images, and video. We can use Azure Machine Learning to be able to create our own bespoke solutions. Azure Databricks and Azure Synapse Analytics can be used to create bespoke machine learning solutions. And we also have broader capabilities like Azure HD Insights, which enable us to have a kind of infrastructure as a service version of Spark, Hadoop, and a number of other key capabilities. We can then store our real-time data in any number of ways. So we can write that data once we've got an insight into a traditional relational database. We can add it to Cosmos DB if it's in a JSON format and needs that kind of rapid querying capability. We can store it in Azure Table Storage or Blob Storage. And we can even then persist it inside Synapse Analytics or Azure Databricks. And finally, we can visualize our data. When we write code in Synapse and Databricks, we can use Python and our libraries to visualize our data. We can use Power BI, and we can use Azure Data Explorer, which is now also part of Synapse Analytics. So there's a whole raft of technology options for us. And we really need to, and thinking about it in these modular stages and being able to think about the right technology enables us to put events and things in between the different stages to help us decouple our solutions. And by decouple our solutions, I mean that we can more readily use different technologies for the different stages so that we can meet our requirements, which could include cost, scale, internal skill sets, and other common considerations. So normally I would build the solution using Azure Databricks or Azure Synapse Analytics with some cognitive services for my custom AI. But unfortunately, due to a recent rebrand and release of some packages, the cognitive services consuming function package that's suitable for Spark isn't currently downloading inside my Databricks clusters. So today I'm going to do a lot of this actually with Logic Apps, both as a listener and to get that insight and store it into blob storage and then analyze it in Power BI. So our signal that I need you to be doing today is tweeting with the Datamines hashtag. So I'm going to look for Datamines on Twitter to be able to get the data. And I'm going to post that to an event hub so that it enters our system for our real-time processing. Before I create that signal and listener, does anybody have any questions?
I don't see any questions in the chat either, so I think we are all clear right now.
So this one I'm going to stick with. Here's one I made earlier, just because it has a number of different pieces. But we do have some different aspects. So real time is a highly variable concept for people. And it really kind of works probably on the amount of time somebody needs to be able to make a decision based on the data. So if somebody only needs to make the data once a day, then you only need to load the data every day. But we can set a frequency of updates for when we have to poll a source for information. We then have a Twitter connection. And we're going to search for Datamines and bring back some data. We're able to read our images, be able to read our tweets, get information about them, including the URLs for any shared images, perform a HTTP request to get those images, and then store them, and then be able to provide an event relating to them. Similarly, we can get the information about the tweets and then add the tweet to an event so that we can process those. By putting these in two separate event hubs, we can process them independently because we have two different volumes. Tweets tend to be more frequent than tweets with images. I'm going to manually trigger this. Okay, and we can see that this started checking and had some images because it was trying to input the same file multiple times. Fix that. So we get a coding language inside the logic apps, which is very similar to capabilities in Power Automate, if you've seen that. And I think I managed to break this. But it is one of the big advantages of the no-code capabilities is that we're able to make these changes fairly quickly and be able to see their impact and try them out in real time. And we're able to see it go through. We're able to see the information for each part of our data if we choose. And have it loop through as many events as it needs to process in order to succeed. And we can go take a look, make sure this is generating some blobs in our solution. So we can see we're getting folders and data being stored in our system. So this is giving us an event that is in our Azure Event Hub. And we can see we have events coming in, and we can look at that volume to be able to manage our solution, scale it appropriately. So we have our real-time aspect. That's our signal. And I have a little bit of a listener out for tweets. If it was a fully reactive one, it might be working whenever a new tweet occurs, but those searches have to happen on a polled basis. But before we move on to start building something that will listen out to the new events and be able to send information to our AI solution to be able to get insight back, does anybody have any questions?
I am not seeing any questions in the chat window, so no questions
Okay.
right now.
Okay. So now that we have our events happening in our system, I'm going to build a new logic app. So I'm building these in a decoupled way. So each logic app performs a discrete task. And the idea is that by modularizing the scopes of what each solution does, it means we can switch them out. So logic apps have a pay-as-you-go execution model, but that might end up being more costly or unsuitable if you were trying to stream and process thousands of events per second, at which point you might move into an alternative solution. And by keeping your thinking about the scope of the work to a very narrow task means that we're able to swap out to appropriate solutions much more easily and prevent a very large change needing to occur. So this one is going to be the image processor. And logic apps can also work with on-premises data sources. So this isn't just a real-time pipelines that you can build in the cloud. You can also integrate with your on-premises solutions. So I'm going to start with a blank application. I'm then going to work with event hubs as my trigger. So whenever an event about an image being posted happens, I'm going to listen out for it. But there are more than 300 different connectors that you can work with in logic apps. Yes, I'm very much selling logic apps because it is a lovely tool for us. So when events are available in Event Hub, in our images hub, we're going to get some images. And again, I'm going to check every minute. I then want to use AI to be able to analyze those images. So I'm going to use the computer vision API. I'm going to use the latest version. You can either send an image to cognitive services to be analyzed or send a link. Because we uploaded the images to blob storage, we can send the blob storage URL to be analyzed. That stops you from shipping as much data around, which helps improve your processing times. So I'm going to get the URL from the event content. That's going to send it to the image analysis. And then I'm going to write the JSON from that image analysis to blob storage. I'm going to add these to AI images, which is my folder inside the blob store. We can see here, connect with that. I need a name for my solution. for what I'm going to create. I have a URL of the blob, the image that I originally analyzed. So I'm going to use that to give me a safe blob name. So I can encode my URL to make sure it doesn't have any dodgy bits and pieces in the name. And I can then use some dynamic content. I can use the URL from my trigger in my event hub and click OK. And then the content that I want to write is the JSON from the analysis. So I can add the body of the response from my API. I'm going to save this. And then I'll run it now. Clicking things always makes things go faster. There we go. So this is processing. We had an event. This is base 64 encoded. We sent an analyze image. We sent this image URL. We got a caption of a dog standing on top of a grass-covered field. We had different tags relating to it, and we had categories including that it was outdoors. This then wrote to blob storage this information. So we can now actually, this performs our insight part of the real-time AI pipeline. We're using AI to get information in real time about what's happening, and then being able to store it for consumption elsewhere. Let's just recap that. So we had our listener. For our insight, we're using off-the-shelf solutions. You can replace that API, that computer vision call, with a call to a unique solution you've built. It doesn't have to just be off-the-shelf solutions. You can write your own. You can call a SQL Server store procedure to be able to do something and be able to bring back some information. But fundamentally, we have this process where whenever there is an event, a signal, we're listening to it and we're performing some acquisition of additional insights. We then need to store our data. So you can store data in a number of ways. If the data that comes back from your AI solution is well structured and consistently structured, you might add it into a structured data set format like a relational database, something like Azure Table Storage. If it can be fairly variable, you could add it into Cosmos DB, and you can also store it in Parquet inside a data lake environment. Or once you have the analysis, the insight, you could, and you needed to do more processes, you could even post it back to event hubs to say, hey, I finished my part of the process. Here's the information needed. Now go do whatever you want with it. So you can, again, kind of add more and more stages to the pipeline through posting repeatedly to different event hubs, reflecting the stage of the processing that you are at with your real-time data. So let me build one of these for the tweets as well. I want the resource group, not the subscription. I have to do a lot of screenshots for different things, so that's why my subscription is called Contoso. So I automatically look like I have a case study. I'm going to create a logic app. So when this one's going to be created, I'm going to start working on our tweet content to understand that. So we're going to listen to an event hub again. Only this time it's going to be the tweets. We're going to check every minute. And this time, I'm going to want to do some text analytics. And we have a number of different options. So detecting personal information is important. We can get information, links to external knowledge bases like Wikipedia, that's mentioned, that's great for studying. But in the case of analyzing Datamines or a conference, something like key phrases might help us understand what was most important about the conference. What were people talking about? So we can perform a key phrase piece of analytics. We then need to provide some information. So we can go to our cognitive services resource and be able to get some critical information. So we need our keys and our endpoint. We can provide our URL. So we need some information from our content. We need some input text. I'm going to analyze the content of our text. And I'm going to leave the language optional so that it can detect which language it's going to analyze. And then this is going to, again, I'm going to put it into a blob storage for now, purely because the alternative way I did this had it all going into event hubs. And I just want to make sure that we get everything right. We can do AI tweets. We can create a blob. And I'm just going to create a GUID for now. So I'm going to give it a random name. And then the content is going to be the response from the key phrases API. And this one I definitely haven't tested before I started building. So let's see if this works. Okay. So we have lots of tweets that we're analyzing. This has gone and gotten the content. We have a key phrase, so a testing Datamines. This is currently waiting for that to execute. So let's see if any of the others have finished. Probably shouldn't have pressed the button quite so much. So this is for every event that's been posted. This can really start scaling. One that succeeded. This is the one that will be picked up. Information that it analyzed. We've got key phrases, Steph Locke, Datamines, and we've got the other person's Twitter handle. And it's then gone and created documents. So now that we have image analysis and tweet analysis, we can go to Power BI. No, you're not Power BI, you're Power BI. We can get data. We can go to Azure Blob Storage. Unfortunately, I don't have Zoom It on my machine at the moment, but I'm going to get the URL for my storage account. Get the URL. Where is my connection? My endpoint again. If you haven't started using it yet, the start key plus V, so the command key and V gives you a clipboard widget, so you can remember multiple things, which comes in super handy at times like this. And don't worry, normally I'd keep my keys secret, but I'll be deleting this in an hour or so. Not PowerPoint, Power BI. So we'll put a key in here. When it's responsive, it completely loses some of its information that I need. That's what I need. So we can connect to our blob folder. We have information with attributes about the file name, and the contents. We can explore the contents. And now we have our categories, tags, description tags, and description captions. So we can expand to new rows, expand out. We can get the categories and names. I'm not doing this properly in the interests of time, but we're able to get tags, categories, descriptions, tags. And our captions, including our lovely a close-up of a dog. So now that we have this information, we can actually start then doing things like looking at tags and which ones are the most popular. So indoor currently being the most popular across the different pieces, and we can start building this up and then set this with its blob storage as a scheduled refresh source to be updated on a regular basis. Or if we needed to be able to analyze this data in more real time, we could provide the inputs as well as to blob storage to an event hub to be processed further in a streaming solution to be able to aggregate and produce a real-time data feed for Power BI. I usually do that myself with Databricks, with the recently called MML Spark, now Synapse Spark app that enables us to push data to Power BI, but we can also do this slower cadence through blob storage or table storage with regular updates. So we've stored our data in blob, and then we've been able to visualize our data in Power BI. That makes it a very end-to-end demo. Usually I would use Databricks for a lot of it because you might have custom solutions. It gives you streaming capabilities and a great new storage mechanism called Delta with a Delta Lake, where you can store transactionally into Parquet files to be able to retrieve point-in-time versions of the solution and be able to stream data in as it arrives, but be able to perform batch analysis on the overall tables. So thank you very much for listening. I'll do a quick show of the solution step by step as a recap, and then I'll have more time for questions. Zoom in again. This might even be too big, but with a 4K screen, it can be tough to tell for folks. So we start off with an event hub, a way to get a real-time signal into our Azure environment. We populate that event hub by looking at a source that is fairly real-time for us, which is a Twitter feed. So it's regularly looking on Twitter, getting information about data sources like images and tweets. It's then adding those to an event hub whenever it finds them. So that's our data, our signal is our Twitter, our listener is our Logic app. And then we become, after that polling situation, we become event-driven. So we listen out for new events saying, hey, we've received a tweet. We're using AI to understand what's in the image or understand the contents of the tweets. We're taking this insight and syncing it to a blob storage solution. And then once it's in a blob storage solution, we're reading that data in Power BI to start understanding what's inside the tweets and the images that people are talking about in our brand. So you could be doing a similar process with events from manufacturing machines or from sales from a retail solution, or through emails for service desk alerts. There's all sorts of things in the world where we can be reactive to events that happen, to be able to gain insight more quickly, to be able to perform earlier interventions, automated decisions, and be able to build up this enriched data set as you go throughout the day to help be always up to date and improving how frequently you can make certain decisions. So thank you all very much. I appreciate you tweeting. The Datamines tests were great. I have some additional slides for and I'll share the PDF for how some of these things can be implemented for different situations. Some background for you for if you need it on event solutions, logic apps, the Azure ML environment, what used to be MML for Spark, which is now Synapse Spark, and Delta Lake solutions, because these are a great way to scale a data enrichment pipeline that primarily depends on Spark. So does anybody have any questions or want to see any other pieces of information?
We have 2 questions right now in the chat.
Mm-hmm.
Can you briefly reiterate on the point and the advantage of using something like Bicep?
Yeah. We use Bicep a lot over ARM because it is much easier to validate Bicep because it's basically a domain-specific language compared to ARM templates, which have a lot of the functionality baked into strings, which can't be tested easily. So, for instance, as a result, we're able to have snippets that help us with different solutions. So these are out of the box with the extension. Now that I've created this automation account, and like with an ARM template, I can now find, if I create another resource, actually, I'll do it here. So I've got this storage account. I can now say it depends on the automation account. And we start getting help and information about how it's going and why it isn't working. So it's going to be. There we go. So it was able to give me help. I'm also rocking GitHub Copilot as well. So that helps me write code. But this gives full traceability. I can click through to be able to see where it's referenced. It also starts becoming modularized as well. So let me one. Yeah, sorry. I will show you on my GitHub. Or is it my Azure DevOps? We rock we try out a lot of different pieces of tech to see which works. So we wrote a data warehouse structure in Bicep. And this was this gave us the ability to start making components of our solution. So we were able to have a specification for what an ADF setup should look like, the data lake, SQL databases, Azure Purview, lots of different bits and pieces. And then we have a overall deployment Bicep, which has the high level parameters, but also starts having controllable flags as to what gets deployed. And then inside our deployments, we're able to pass whether they should be, the different sections should be used. So we can easily spin up a fully configured environment with lots of different pieces that meet a solution architecture that we agree with a specific company, but still be able to use exactly the same code base to do that deployment. So it's really super handy. I cannot recommend Bicep anymore. It's just amazing. It's so much better than templates for being able to build up with quality and improve the developer experience substantially. Okay, I'm gonna stop hearting Bicep. What's the second question?
So second question is more on the data visualization side. Would you recommend any other alternative data visualization solutions in the Azure cloud? So Azure-based data visualization solutions.
At this point, not especially. So I've done, I'm a big fan of R. I've deployed Shiny applications into Azure Web Apps in containers to be able to deploy those easily. That's great if you have Shiny or Dash from Plotly, that kind of solution. There's a new Grafana preview that could be useful for helping visualize time series data. Azure Data Explorer can also, which is also now part of Synapse, so Synapse Data Explorer is also quite good for producing some visuals for, again, that kind of time series log-like data. But right now, I'd say Power BI really is kind of the best of breed Microsoft solution, and the amount of data sources it consumes so easily is tremendously valuable.
Okay, so that is all the questions we have in chat.
Well, thank you very much, everyone. I'll post the slide. I'll give Benny the slides and the GitHub URL and stuff. One of the differences that I usually do of this is I usually build the solution in Spark capability, so in Databricks or Synapse, and that has the advantage for people who are code first, and it can be more effective if you're dealing with like a very high volume that you want a fixed cost allocation for. So there's inside the Git repository, there are notebooks for that, but when Microsoft renamed the package that does the cognitive services interactions, that has I haven't had chance to fix that because the package doesn't download to my Databricks at the moment. But the advantage of having an event-driven solution is there are many things which can process events, so all was not lost.
Okay, great. That's all the questions. Steph, thank you for presenting. This was really interesting and really useful.
I'm glad you found it useful. Hopefully everybody can go and play with something like Logic Apps and build a little solution that processes data and uses some of the cognitive services.
Yeah. So out of my curiosity, what would you say, ballpark? You don't have to go into the Azure consumption to set this up and to let it run for a day. How much would you say that it costs to get this running in Azure consumption?
The cost scales with the number of events. with the consumption tiers. So if you had like 1,000 events, it might cost you less than 50 cents to run.
Which is nothing.
Like 10 cents probably, but I try to give some hedge in the figures so that people, because the logic, the event hubs are incredibly cheap. They're you're not going to hit the throughput beyond the free tier type of thing without having thousands of events per second. The logic apps are pay per execution, and they're kind of thousandths of a cent to run per execution, per block on the logic app. And then the cognitive services are something like 50 cents per 1,000 calls, maybe. The price is getting cheaper all the time. And there's a number, and you get like a free number of executions as well.